We're going to look at dividing polynomials today. We're going to first of all start off with longhand division. We're going to take 85 and divide it by 4. So 85 goes inside the half box, 4 goes in front, and then you ask yourself, okay, 4 times 1 is 8, and you know that that's 2, so you put a 2 up above, and you got to go your 2 times your 4 gives you your 8. Now you subtract 8 minus 8, and that gives you 0, which we're not going to write. Bring down the next term, and then you repeat. 4 times 1 is 5. Well, nothing exactly, but 4 times 1 is closest to 5 that we can get without going over. So your 1 times your 4 is 4. Now we're going to go ahead and subtract. We get 1. So your answer is really just your quotient, which you have on top, and your remainder over your divisor of 21 and 1/4, which is really a 21 plus 1/4. So your answer is 21 plus 1/4, or you could write it as this right here. Now your book may be wanting you to write your answer as this, your divisor, which was our 4, times our quotient, which is our 21, our answer on top, plus your remainder, which in this case was 1. So let's go ahead and do longhand division here. So this is going to go inside our half box, this will go in front, and then we're going to do a very similar process to what we did before. So you go x times what is x squared, and in this case that's an x, so I'm going to put an x on top. X times x is x squared, but I also need to take my x times minus 5. So basically whatever you put on top, you're going to multiply by everything in front. Now when we were doing it before, we said this minus this. We can do that, but sometimes it gets confusing. So instead of subtracting, we're going to just add the opposite. So I'm going to switch all my signs here, and then all I'm going to do is add down. This plus this is 0. This plus this is a 3x. Now I'm going to just bring down my next term, and now I'll repeat. Now I'm going to take my x times what is my 3x, and in that case it's just a 3. 3 times everything in front, 3 times my x, 3 times that negative 5, switch my signs, and add. The 3x's drop, the 15's drop. So your answer is really just your quotient, which is your answer on top, plus your remainder of 0, or it's your quotient, your answer on top, plus your remainder over your divisor, what you have in front. So let's go ahead and see if you can do longhand division on this problem here. This would go in your half box, but since you're going ahead and missing some terms, your cubic, your quadratic, and your linear terms, you need to put the zeros in front of those as placeholders so that everything is lined up nice and neat. So see if you can work this out. So pause the video while you try it. So we need to go ahead and do the same thing. Our x squared times what is x to the 4th. In that case, that's an x squared. You take your x squared times your x squared, you get an x to the 4th. Your x squared times your 3x. Your x squared times your 1. Then you want to switch all these signs, and then you want to add. These drop, these give you a negative, these give you a negative, bring down your next term, and then repeat the process. Our x squared times what is a negative 3x cubed? Well, in that case, that's a negative 3x. So we got to take a negative 3x times each one in front. And the negative 3x times the 1. Switch all of our signs. And add. These are going to drop. These are going to give you a positive 8. These will give you a positive 3x. Bring this down to negative 16. Now we repeat. Our x squared here times what gives me an 8x squared? In that case, that's just an 8. 8 times your x squared 8 times your 3x, 8 times your 1. Then we switch our signs and add. These drop, 3x plus a negative 24x, and add these. So when you divide these two, that's what our original problem was. You could write your answer as your quotient with your remainder. Or you could write it as your quotient with your remainder over your divisor. Now, sometimes in your homework you'll have to write it in the first way, sometimes you have to write it in the second way. So look at what your homework is saying. So now let's take a look at synthetic division. Synthetic division, you start out with a half box here, and in this case we're going to put a 5 in it. You might be wondering, why are we putting a 5 there? It's always the opposite of what's after the x. Then we're going to put down a 1, a negative 2, and a negative 15. So we have our 1 coming from our squared term, our negative 2 here, and our negative 15. So there's no variables here. With synthetic division, you add and multiply and repeat in that order. So we're going to add this plus what's underneath of it, which is nothing, so it's not going to change it. We multiply our 5 times our 1. Tells us what to put here underneath the next term. We add now. We now need to take our 5 times what's in the bottom to tell us what to put here. And then we add. And so then we get a remainder of 0. This is your quotient. If you started out with an x squared, your quotient's going to start out with an x to the first. It's always one smaller in power. So this is your x to the first, so it's a 1x. This is your, then what's after that, which is your constant. And this is the exact same answer that we got when we did it the first time using longhand division. So let's go ahead and do this one here with synthetic. This one here, we're going to put a 2 in our half box because it's always the opposite of what's after your x. Put down your coefficients and your constant, a 1, a negative 4, a 6, and a negative 4. If you are missing any terms here, you'd have to put a 0 in as a placeholder. Then once again, we just multiply, or add and multiply. We take this plus this, we get 1. Our 1 times our 2 tells us what to put here. We add now. We take our negative 2 times our half box, tells us what to put underneath the next one. Then we add. Our 2 times our half box tells us what to put underneath the next one. Then we add. So we get a remainder of 0. We started out with an x cubed. So this is going to always be 1 smaller than that. So it's going to be a 1 in front of our x squared, a negative 2 in front of our x to the first, and our constant. So whatever you start out with here, it decreases by 1 exponent each time as you go across. So let's go ahead and take a look at this one here. The easiest way to do this one is to write it as 3 fractions. The first term over the bottom, second term over the bottom, our last term over the bottom, just writing it as separate fractions. Now all we want to do is reduce. Well, you notice your x over your x, they drop. Which one has more y's? The top does. So the y in the bottom disappears. And we have this. Then we look at the next term. You'll notice you have an x in the top and the bottom. You have a y in the top and the bottom. So you're just left with a 3. Over here we have an x in the bottom. We're going to drop with an x in the top. So you're left with that. And you have a y in the top and the bottom. They're going to drop. So you're going to write it as this. Now, this problem up here could have been written in this form here, and it would mean the exact same thing.